Good day, everyone. Welcome to my YouTube channel, Abiodun Metrics at Metrics Ed. At the end of this video, don't forget to like, share, and subscribe. Now, our next talking point, as I promised in our last class, are prime numbers, factors, and multiples. Prime numbers, factors, and multiples. Prime numbers. What are prime numbers? We define prime numbers as numbers which can divide one and itself only. I'll go again. Prime numbers are numbers which can divide one and itself only. That is, when is that we have a particular number, specifically natural numbers, as I told you in our last class, that natural numbers are normal counting numbers which ranges from 1 to infinity. Now, when is that you have a natural number and such number can divide just one and itself only, so we refer to such number as a prime number. Now I'm going to list natural numbers ranging from 1 to 20. 1, 2, 3, 4, 5. Now let me stop there. Now let's start with the first natural number, 1. Now, is 1 a prime number? We say no. Because in the real sense, the definition of prime number is that numbers that can divide one and itself only. But if it's that you look at 1 as a number, there's no difference between 1 and itself of 1. Now, for that reason, we say 1 is not a prime number, because what makes a number prime number is that it dividing 1 and itself, there must be a disparity. There must be a difference between 1 and itself. So for a number to be a prime number, it divides 1, which is a separated number, and it divides itself, which is also a separated number from 1. So that means 1 and itself must be two distinguishable or different numbers. So now, for the fact that there's no way we can distinguish between 1 and itself of 1, so we say that 1 is not a prime number. Now 2. Now, we use 2 to divide 1 to give us 2. We also use 2 to divide itself, because itself of 2 is 2. So we use 2 to divide itself, which is 2, to give us 1. Now, for the fact that this condition of 1 and itself as regards the definition of prime number is satisfied, and there is no other number that 2 can divide to give us a whole number, so we say 2 is a prime number. Now the next number after 2 is 3. Now, is 3 a prime number? We say yes. Reason being that 3 can divide 1 to give us a whole number, which is 3. Also, 3 can divide itself. Itself of 3 is 3. So to give us a whole number, which is 1. Now, aside these two, there is no other number that 3 can divide to give us a whole number. So we say 3 is a prime number. Now, the next prime number after the next number or natural number after 3 is 4. Now, is 4 a prime number? We say no. Now, we know that 4 can divide 1 to give us a whole number, which is 4. 4 can divide itself, which is of 4 is 4, to give us 1, which is a whole number. Now 4 as a natural number can divide another number aside 1 and itself. And the other number that it can divide is what? Is 2. So 4 divided by 2 will give us 2. Now, for the fact that the condition of the definition of prime number is exceeded due to this, because aside 1 and itself, 4 can divide another number which is 2. Now, for the fact that that condition of 1 and itself only is exceeded, so we say that 4 is not a prime number. Now, the next number after 4 is 5. Is 5 a prime number? We say yes. Now, 5 can divide 1 and itself only. I'll go again. 5 can divide 1 and itself only. Now, we say 5 used to divide 1 will give us 5. We say 5 itself of 5 is 5. Used to divide itself, which is 5, will give us 1. Now, aside 1 and itself of 5, there is no other number that 5 can divide to give a whole number. So in that sense, we say 5 is a prime number. Now, I'm just going to rush through. Don't forget I told you we are going to be dealing with numbers, prime numbers or natural numbers from 1 to 20. I'm going to start with the number after 6. I'll quickly rush through it. After 5, which is 6, I'll quickly rush through it. Is 6 a prime number? We say no. 6 is not a prime number because ordinarily 6 divides 1 and itself. And we know that 6 can divide another number, which is 2 and 3, to give a whole number. So 6 is not a prime number. Now 7. Is 7 a prime number? We say yes. 7 is a prime number because 7 can only divide 1 and itself. It cannot divide any other number to give a whole number. So we say 7 is a prime number. Is 8 a prime number? We say no. 8 is not a prime number because aside 1 and itself, 8 can divide other numbers like 2 and 4 to give a whole number. So we say 8 is not a prime number. 9. Is 9 a prime number? We say no. 9 is not a prime number because 9 can divide 1 and itself, which is fully established. But 9 can divide another number, which is 3. So we say 9 is not a prime number. Now 10. Is 10 a prime number? We say no. 10 can divide other numbers like 2 and 5 to give a whole number aside 1 and itself. Now the next is 11. Is 11 a prime number? We say yes. 11 can divide only 1 and itself, and there is no other number that 11 can divide to give a whole number. Now 12. Is 12 a prime number? We say no. 12 is not a prime number because aside 1 and itself, 12 can divide other numbers like 2, 3, and 4 to give a whole number. Now 13. Is 13 a prime number? We say yes. 13 is a prime number because 13 can only divide 1 and itself. Now 14. Is 14 a prime number? We say no. 14 is not a prime number because 14 can divide other numbers like 2 and 7 to give a whole number. 15. Is 15 a prime number? We say no. Aside 15 dividing 1, aside using 15 to divide 1 and itself, 15 can divide other numbers like 3 and 5. Now the next number, 16. Is 16 a prime number? 16 is not a prime number because 16 can divide 2 aside 1 and itself. Now 17. Is 17 a prime number? We say yes. 17 can only divide 1 and itself. Now 18. Is 18 a prime number? We say no. 18 can divide 2 6 and 9 to give a whole number. Now, 19, is 19 a prime number? We say yes. 19 can only divide 1 and itself, and aside 1 and itself, it cannot divide other numbers to give a whole number. Now, 20, is 20 a prime number? We say no. 20 is not a prime number because 20 can divide 2, 4, 5, and 10 to give a whole number. So between 1 and 20, we have successfully listed out all of the prime numbers that we have. So we say prime numbers between 1 to 20 as natural numbers. We have 2, we have 3, we have 5, we have 7, we have 11, we have 13, we have 17, and we have 19. Now, all of those numbers are prime numbers that ranges between 1 and 20. I'll go again. Prime numbers. Numbers that are divisible, that are used to divide 1 and itself to give a whole number. So I'm going to put you on the spot as regards you identifying prime numbers based on my explanation. So you identify prime numbers between 21 and 100, and I will appreciate if it's that you can give me the response in the comment section. Our next talking point after this is what we call factors. Factors. Now, in the real sense, we call numbers that can be broken down into prime numbers, we call them prime factors. Prime factors. What are prime factors? Prime factors are prime numbers that are obtained by breaking down a bigger number into multiplicable prime numbers. I will go again. Factors are multiplicable prime factors that are broken down from a large number. Now, there are two ways in which you can obtain the prime factors of a number. The first is what we call the long division method. So, the long division method. And the second is what we call the tree method. The tree method. Now, we are going to use these two methods to obtain the prime factors of a big number. Now, I'll give two examples and I will use each of these methods to solve for the prime factors of that particular number. Now, example. Obtain the prime factors of 1, 20, 2, 36. Now, as I promised earlier, I told you that we will use the two methods applicable to solve for the prime factors of bigger numbers, which are the examples given 20 and 36. And the methods applicable used in solving for the prime factors of a number are the long division method and the tree method. Now, the first question, using the long division method to obtain the prime factors of 20. I'll write 20 and draw a vertical line. I'll write 20 and draw a vertical line such that I'll be using that number 20 to divide the prime factors until it can no longer divide a particular prime factors, and we keep moving on till 20 automatically becomes 1. Now, this first prime factor is 2. We know that 20 can divide 2 to give a whole number. So in that sense, we say 2. 20 used to divide 2 will give us 10. We go again. Can 10 still divide 2 as a prime number? We say yes. 10 used to divide 2 will give us 5. Now still on 2. Can 5 divide 2 to give a whole number? We say no. So we move on to the next prime factor or next prime number after 2, which is 3. Now 3. Can 5 divide 3 to give a whole number? We say no. We move on to the next prime number after 3, which is 5. Now 5. Can 5 divide 5 to give a whole number? We say yes. So 5 used to divide 5 will give us 1. Now we eventually arrived at 1, breaking down 20 to form 1. So that means we can't go any further. So that means the prime factors of 20 using the long division method are 2 times 2 times 5. So this implies that 2, 2, and 5, which are the numbers multiplied together, or is expressed as the prime factors of 20, when being multiplied together, will still give us 20. We go 2 times 2 is 4, and 4 times 5 is 10. It's 20. So we say that 2 times 2 times 5 are the prime factors of 20 using the long division method. Now the second method, which is the tree method, you write your number 20. You write your number 20 and you draw branches for that 20. 2 branches first. Now you think of 2 numbers such that when you multiply those 2 numbers together, you arrive at 20. Now, some of the numbers, when being multiplied together to give me 20, are as follows. Some numbers, when being multiplied together to give me 20, are as follows. I can multiply 4 and 5 together to give me 20. Likewise, I can multiply 2 and 10 together to give me 20. So these are the only numbers in which, when multiplied together, can give me 20. So I can decide to go with any one I so desire. So let's go with the first one, which is 4 times 5, to form the branch of the number 20 using the tree method. So I'll go 4 times 5. Now, after doing that, of the 2 numbers that I multiplied together to give me 20, which forms the branch of 20, I would think, is anyone the prime number out of those numbers? I would say yes. 5 is a prime number, so I would circle 5. So that means I can't further break down 5 into prime factors because 5 is already a prime number. But I can still break down the other number 4 into prime factors, whether all be prime factors or a particular certain amount of number being prime factors. So I'll form another branch for 4. I'll go. What numbers would I multiply together to give me 4? I know 2 times 2 is one of those numbers. 4 times 1 is also one of those numbers. But there will be no need multiplying 1 by that exact number because it will be of no use in that sense. So I will go with 2 times 2. Now, breaking down 4 into branches, we have 2 times 2. I'll now check. 2 times 2, is there any prime number between those two numbers? I'll say yes. The two numbers are even prime numbers, luckily for us. So that means for the fact that we've circled out all of the branches we have in 20, it implies that we've successfully used the tree method to break down 20 into prime factors. So I would go. So our 20 being broken down into prime factors would give me, in a particular order of increasing prime numbers, that will be 2 times 2 times 5, which is the same as what we got using the long division method, the tree method. 2 times 2 times 5. Now the next example after this is 36. I want to break down 36 into prime factors. Now the first method, the long division method, as I explained to you, you rule a vertical line and you write your number 36. Now we use 36 to divide prime numbers, starting with the list. Now the first prime number that we have is 2. Now 36 can divide 2 to give a whole number. So we write 2. 36 used to divide 2 will give us 18. 18. Now still on 2. Can 18 divide 2 to give a whole number? We say yes. 18 used to divide 2 will give us 9. 9. Now still on 2. Can 9 divide 2 to give a whole number? We say no. So we move to the next prime number after 2, which is 3. Now, can 9 divide 3 to give a whole number? We say yes. 9 used to divide 3 will give us 3. Still on 3 as a prime number. Can 3 divide 3 to give a whole number? We say yes. Now 3 used to divide 3 will give us 1. So we've eventually arrived at 1. Now we say that the prime factors of 36 would be 2 times 2 times 3 times 3. So that means we've successfully broken down 36 into its prime factors, which are 2 times 2 times 3 times 3. Now if you multiply those prime factors together, you still eventually arrive at 36. Let's try that. 2 times 2 is 4. 4 times 3 is 12. And 12 times 3 is 36. The long division method to obtain the prime factors of 36. Now, let's obtain the prime factors of 36 using the tree method. You write your 36. You now draw branches. 2 branches for the number 36. Now you think of 2 numbers such that when you multiply those 2 numbers, you will get 36. Now there are many examples of such. Now 36. We have 6 times 6. 6 times 6 will give us 36. Now 36. We have 2 times 13. 2 times 18 will give us 36. 2 times 18 will give us 36. Now we have 36. Another number, 4 times 9 will give us 36. And there are some other numbers too, such that when you multiply together, you can get 36. For instance, now 3 times 12 will give us 36. Now that means that you can so desire, you can by your own will pick any numbers that you have highlighted for you that eventually results in 36. 6 times 6 is 36. 2 times 18 will give us 36. 4 times 9 will give us 36. 3 times 12 will give us 36. Now, I would go with 2 times 18. 2 times 18. So that means I've created a branch for 36, and the one I decide to choose is 2 times 18. So I would go 2 times 18 will give me 36. Now, between these two numbers, 2 and 18, I already have a prime number, which is 2. So I'll circle the 2. I'll draw a branch for 18. I'll think again. What other numbers will I multiply together to give me 18? Now, because of time, I'm just going to pick one, but I'll just say the others. Now, we have 6 times 3. 6 times 3 will give us 18. 9 times 2 will give us 18. Those are the two numbers such that when you multiply together, it will give us 18. Now, I decided to go with 6 times 3. Now, between 6 and 3, which is a prime number, 3, I would circle that. That is done. Now, I'll move on to 6. I'll draw a branch for 6. I will think of two numbers such that when I multiply together, it will give me 6. And the only number is 2 times 3, aside from 1 times 6. And I told you, using 1 to multiply that same number will take no effect. So that means it's just as if we are still retracting, or we are retracting our step by using 1 times that number back. So you think of other numbers. And by the way, 1 is not a prime number. Any number used to multiply a particular number is that number. Now, 2 times 3, I will not think. Between these two numbers, which is a prime number? The 2. 2 and 3, they are both prime numbers. So that means invariably, the prime factors in a particular order of how we have prime numbers in natural numbers. I'll go 2 times 2 times 3 times 3. Now, those are the prime factors of 36. Now, 2 times 2 times 3 times 3 is the same as what we got when we used the long division method in our previous example. So now let's confirm to see if it's that when we multiply those numbers together, it will give us 36. Let's go. 2 times 2 will give us 4. 4 times 3 will give us 12. And 12 times 3 will give us 36. So those are the prime factors of 36. Now, I want you to also take this as a study question to obtain the prime factors of number 1, 50, number 2, 112, and number 3, 630. So obtain the prime factors of these numbers and tell me what your answer is. I would be expecting your response in the comment section. Now, our next and final talking point is multiples. Now, multiples is obtained from the word multiplication, which is an arithmetic symbol or sign used in mathematics. I will go again. Multiple from the word multiplication. So multiple is obtained from the word multiplication. And what does it mean? It implies that when is that you are given a particular number to obtain its multiple, you can only obtain its multiple by using such number to multiply bigger numbers or to multiply numbers like 2, 3, 4, 5, 6, 7, and so on and so forth. So you might be told to list maybe the 5 multiples of a particular number. For instance, if you are told to obtain the multiples of 50, so what that implies is that in order obtaining the multiples of 50, you use 50 to multiply numbers like 1. So 50 times 1 will give us 50. You use 50 to multiply 2. 50 times 2 will give us 100. We use 50 to multiply 3. 50 times 3 is what? 150. You use 50 to multiply 4. 50 times 4 is 200. You use 50 to multiply 5. Times 5 is 250, and so on and so forth. Now, you can't be told to list all of the multiples of a number. You will only be told to list a certain amount of the multiples of a number. For instance, if you are told to list the first 5 multiples of 50, so the first 5 multiples of 50 will be 50, 100, 150, 200, and 250. So that means we'll be using 50 to multiply 1, 50 to multiply 2, to multiply 3, and so on and so forth. Now, that is that for 50. Now, let's pick another number. 32. Obtain the multiples of 32. Don't forget, I told you, you start with 1. You use that number to multiply 1, 2, 3, and so on and so forth till you get to a much larger number. And there are times questions can come that you should obtain the multiples of a number in no particular order. That means you can decide to use that particular number to multiply 10 to give us a higher multiple. You can use that particular number to multiply 50 to give us a higher multiple. You can use that particular number to multiply 15, 35, 70 to give us a larger number. But it is always safe, unless otherwise stated, it is always safe to go in that trend of natural numbers: 1, 2, 3, and so on and so forth. Now let's go. The multiples of 32, we say 32 times 1 is 32. That is the first multiple. 32 times 2 is 64. The second multiple, 32 times 2 will give us 96. 32 times 3 will give us 96. The third one. Now the fourth one times 4 will give us 128. 128. Now let's do the next one. 32 times 5 will give us 160. Now the next one, 32 times 6 will give us 192, and so on and so forth. So I can go to a much higher multiple. I can say 32 times 10 will give me 320. 32 times 100 will give me 3,200. 32 times 50 will give me 1,600. So these are much larger or higher multiples. And like I said, questions can come where it's that you are told to list a much larger or higher multiple of a given number. Now, another way of obtaining the multiple after obtaining the first multiple, that is using that same number to multiply 1, is that you'll be adding the number to that particular number. Now, for instance, the first multiple is 32. Now, if you add 32 to 32, it will give us 64. If you add 32 to 64, it will give us 96. If you add 32 to 96, it will give us 128. If you add 32 to 128, it will give us 160, and so on like that till you arrive at a desirable number of a multiple of a particular number. So I believe I've been able to do justice to the topics treated, which are prime numbers, factors, and multiples. At the end of this video, please, I want you to subscribe, like, and share for more videos. Thank you.